Hi, this is Jared Stout on the final exam, part 1, the physics principle demonstration. This demonstration I will be doing is going to be a part of Newton's third law of motion. As stated, whenever one object exerts a force on a second object, the second object simultaneously exerts an equal and opposite force on the first. So in order to understand this law of motion, we have to realize that there are two different parts to this law. The first part is called the action force, and then the second part, or second force, is called the reaction force. Explained in our textbook, to every action there is always an opposed equal reaction. For example, when you push on a wall, the wall pushes back on your fingers with equal and opposite force. That is why if you touch someone, then they touch you back. You can't touch someone without being touched back. It's equal and opposed. Just like when you push your fingers together, you can see the same amount of discoloration on each side of your finger. That is proof that they're experiencing the same amount of force in opposite directions. One of the coolest parts about this law is the example I'm about to show. Here I am on a longboard with a 10-pound medicine ball. We understand systems, and the system we are looking at is me, the longboard, and the medicine ball. The medicine ball is currently inside the system, so there is no change in momentum to our system. However, when we exert a force on the ball and push it away from us, the ball is now external to our system and pushes back on us with equal and opposite force. Here is the same experiment done on a 20-pound ball. And here's the experiment with a 30-pound ball. No movement to the system. And then, if you noticed in that experiment, sometimes I didn't go very, far or fast, depending on like the weight of the ball. Like when I pushed on the 10-pound ball, it was a less of a reaction than when I pushed on the 30-pound ball. And that is because we can only impart as much momentum as the reaction force can push back on. For example, like I am 230 pounds and I was pushing a 30-pound ball. So there's a 200-pound resistance there. Just like the example in the textbook that a boxer, when he punches a punching bag, it leaves a dent, and it's a hard hit. However, when you punch a piece of paper as hard as you can, regardless, it's only going to impart back the mass that it is able to. And that's the same situation with my Nike 270s. When I drop it to the ground, the earth is pulling on this mass as much as it weighs, right? And in the same opposite equal reaction, the shoe is pulling up on the earth with the same amount of force that it takes to pull the shoe down. The same thing happens with a gun and a bullet. I wasn't sure if I was able to show that, but my gun, basically what happens is the explosion inside the bullet chamber pushes this small mass of the bullet out, but it has an equal and opposite magnitude back on the gun, either pistol, cannon, rifle, whatever you use, and they are equal and opposite in magnitude. However, the acceleration and the mass depends on what it is. If they're equal mass, they're gonna have the equal acceleration back. That's why it's kind of crazy when you see someone in the movies and they get shot by a shotgun and they go flying across the room. That's not right, right? But with a bullet, it's a much smaller mass, so it has a much larger acceleration. And so it goes off that way.